Welcome to the channel where all you gotta do is, well, lots of stuff, but in this case, we're gonna flow a cylinder head. So I'm building a 68 Mustang Fastback. And of course, the first thing you want to do when building your car is cylinder head flow work, because that makes no sense at all. But anyway, I found this cylinder head on eBay for $7.63 plus shipping. So for $80-ish, I got a cylinder head. Not going to really use it as a cylinder head. I'm just going to use it as a football head, which is what you do when you're developing an engine program. You need to have a casting or at least a flow box of some sort, so you can change valve seat angles, valve sizes, and port shapes, combustion chamber shape, blah blah blah. And if you have a cylinder head, this one's got 5 cylinders on it, so I can have 5 different tries on the intake, 5 different tries on the exhaust to see what works. So, affectionately known as the football head, because you just kick it around until you figure out what you want to do, and then you replicate that on all the cylinders of your build. So, I'm not sure what condition this thing's in, but it doesn't really matter, because matter of the flow bench. As I'm taking it out of the box, I'm noticing some more loose parts, but some head gap or some head bolts and some washers. So it has a lot of the pieces. It doesn't have the cam caps, so you pretty much can't use this cylinder head as anything in a running engine. So I will. It's nice that it has a couple, because I'll need to make a valve actuator doodad, and this will be the clamp for it. So it's kind of good that I have at least one. It'll kind of look like this guy, which is for the Saab, and it'll slide on top like that. Actually, this might actually work. I may just use that. So first thing I want to do is get this thing apart and cleaned up. Those are cute little buckets. I don't know if you know, the S85 has these, instead of a flat tappet, it's got these curved, which allows you to run a little bit more aggressive cam profile than if it was just flat. Not a huge difference, but also they have a key in here to keep it from rotating, and then all this extra material here, which doesn't do anything normally. It's just added weight. So these things are pretty light. Even if you put the oil in them, I'll weigh all this stuff, but it's pretty light compared to the Saab junk, or kind of the direct acting buckets, the 33 millimeter ones that I'm used to playing with. These here are, I would say, smaller than that. Yeah, 28 millimeters. So we'll get this thing apart and we'll get it cleaned up and put it on my handy dandy flow bench over there. Which maybe you haven't seen before. This is a homebrewed jobber. I just pulled the cover off it like an hour ago, and there was what I thought was a dead scorpion lane right here. It's gone. So I think it was just chilling. Well, there might be a scorpion in this video somewhere. Can't say when. They're only like an inch long up here. They're not that big, so I'm not too worried about it. Okay, so I got my jeweler's scale out. Really? Every other one of these things popped right out. So 29.9 grams is what that guy weighs. Pretty light. We'll weigh the rest of the valve train components as well, but that's it's pretty light. The fact that this is stuck is concerning me a little bit. I may have figured out why this is a $7.68 cylinder head. Yep. There you have it. So, get all these valves. Nice, 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 nice. Uh-oh. Not so good. Yeah. There's a problem. It's not airtight. So we may have to do a little bit more persuading on that cylinder to get it off. But well, we have this flashlight out. Get a chance to give this thing a once over. Yeah, it's definitely bent. This head looks remarkably clean. Like remarkably clean. I can hardly imagine this thing ran. There's a little bit of carbon buildup in the corners there. Amazingly clean. I mean, not in there, but not so much down there. But port's super, super nice. I don't know how familiar anybody is with these heads, but basically this is what I call a mini fold. So this whole area is kind of like a plenum of the intake manifold, right? And the idle air motor goes in here, and then each one of these little holes next to the intake port communicates through the individual throttle body, and that's how the idle air is controlled and vacuum to the vacuum brakes and all that stuff. So normally on a ITB motor you don't have that, right? You have, like my ITBs on my Birkin, it uses a throttle position sensor is the only thing that controls fuel. It's pretty mundane way to do it. That's the way it's done. I will fix that. The Sonda, on the other hand, has individual throttle bodies from an S85. Which look like this. And you can see there's the port that lines up with those guys. And cross drill, there's normally a cup plug in there, and then it feeds right back into the throttle body in there. I don't know how well you can see that down there. Yeah, so that communicates with that. So on the ITBs that we put on the Sonda, which are S85 ITBs and a custom intake manifold, yada yada yada, but we have a little manifold down there, and that's where the idle air motor is connected to, and that's where all the vacuum going to the the map sensor and all that junk. So I will do a video on this, what we did on this and why we did it, but today we're going to focus on this S85, see what it flows. I've gone on the internet and tried to figure out what it flows, and seems like the data I found says it only flows about 235 CFM. But a fully CNC ported It should be better than that. So we're gonna find out. So, and then we're gonna decide whether we need to go to bigger valves. This thing only has 35-ish millimeter intakes, which isn't huge for this size bore. A modular Ford has a similar bore, at least the Coyote, and it has a 37 millimeter valve. So, but the bigger the valve you put in there, you're shrouding it to the combustion chamber. So bigger doesn't necessarily mean better. Typically you gain the low lift, but you lose the high lift. But yeah, this is a nice CNC ported combustion chamber, CNC ported intake ports. It's a pretty nice piece, which is why it makes 507 horsepower, normally aspirated. The exhausts look quite a bit cleaner. So, I mean, dirtier, sorry. Filthy, actually. Which is what you'd expect from a $7 cylinder head. Relative motion, there we go. A little heat popped it out. So, maybe this head is kind of okay. So the next thing I need to do is get my valve spring compressor tool, which of course isn't designed for this head. So I'm going to have to see if I have this guy that will work. If not, we'll have to make one. Okay, so I got this guy from past experiences. Not a perfect fit, but I think it should work. Alright. Made the appropriate noise. I see a keeper laying there, and I see a keeper laying there. Look at how little those guys are. Look like motorbike bits. Get our handy dandy jeweler scale out. Huh. Doesn't even register. I have to put 20 on there to get a weight of those keepers. It's a pretty cute little guy though. Look at that. Looks like a burr. This is the only thing between $20,000 catastrophic engine failure and 507 horsepower. Alright, more jewelry. That weighs 6 grams. Beehive spring. Not sure what these white markings on there mean, but probably something. So that's 55 grams. There's the intake valve. Doesn't look terrible. Let's get all this junk off of here. $42 grams. So pretty light reciprocating it. I mean, this thing redlines at 80, 200 RPM, so pretty nice looking valve there for an OEM bit. tearing into this thing. See what we get. Alright, so I got the majority of these off. And I haven't lost any keepers yet. Miracle. The reason for that is what I'm doing, I'm loosening up my spring compressor. So it's got barely any load on it. And then I'm tapping it to try and break the seat wedge lock. Giving it a little bit more. Hear that snap. And then I just tighten it up a little bit and I watch the keepers because they still fall out super easy. They're like infant fingernails. They're so thin. So I can keep track of them by doing this. It's tedious, but low mass has its own reward, especially when it's part of the valve train. So, I don't know if you see what I did, probably not, but back off. Unscrew this thing a couple turns so I don't forget. It'll be obvious because how much force I have to put on it, but they make pneumatic versions of this spring compressor, but I don't know. It just seems like laziness to me. You don't have any feel, so it seems like it's like using a impact gun for torque and rod bolts. No. So this thing is focusing pretty good, but you can see the line right in here where it is ported from this side, and then this is a really nice port. I'm going to pull some plugs off this thing in the future so I can have a reference and measure the cross-sectional areas and stuff, but there's no way a fucking 4.6 Ford flows better than this, and those flow about 255 out of the box. Slightly larger valves, but nowhere near this nice of a port. But we'll see. It's like aerodynamics. Just because it looks like it flows good, that doesn't necessarily mean it does. So I do see a little bit of potential improvement on it, though. The short side is round, so that's not really what you want on the short side. You want the short side to be kind of a D shape. I can explain better with a whiteboard why that is, but that's what the football head's for. We will poke around at it, kick it a bit, and see. I mean, this is what people do for a living. It's what I kind of used to do for a living. It wasn't porting heads, it was designing heads. So I used to just CNC sculpt, like design it in CAD and then sculpt it on a CNC and then put it on a flow bench. Put a plastic flow box on the flow bench and then get a baseline and then start piling clay or Bondo or whatever, making it better, and then trying to replicate that, put it out in CAD, and then CNC, pile Bondo in the flow box again, plastic body filler, and essentially CNC port the flow box again, and then flow it, and then you just keep iterating on that. Sometimes when you get it to work better on the flow bench, and then you try to replicate what it is in CAD, it doesn't end up the same. So sometimes you have to iterate to get it right. And then when you make the core boxes for the cylinder head that actually make the sand cores, you use the same program, right? It's a different shrink factor, but you use the same program. So you should get really close results to your casting versus your CNC ported flow box. So anyway, too much information probably, but we'll go ahead and get these things cleaned up and put it on the flow bench, see what it does. Okay, so our dowel pin holes in, and I have to do a little bit of cleaning and cleanup work on this, deburring and stuff, but we have a 95mm or 92mm bore now, and we should be able to line up with that. Okay, so I got this thing cleaned up, and intake ports, they were cleaned before so we could kind of see those, but exhaust ports, well, they're not awesome. So it looks like they're CNC ported all the way from here to here, and then there's a giant step, and it's right at the short side. There's a step on the inside too you can't see. It's pretty terrible. That's like that on all of them. So it isn't like a one-off thing. That step is a couple millimeters, millimeter and a half, maybe 2 millimeters. I said stay. Yeah, that's pretty shitty. Anyway, we're gonna flow it anyway. It's a football head, so it's also there appears to be an EGR port in every one of these. Like that little hole there. I'm sure that's an EGR port. Instead of just sucking it out of the intake manifold, they know how they keep those from clogging up. You probably don't, but. Okay, so I got this cylinder head all cleaned up, and I need to make a doodad. Maybe less crappy than this. So what I'm going to do is take this piece of 1-inch aluminum bar laying around, and came with a couple of these caps, which are 27 millimeters in diameter. But what I'm going to do is just cut this bar to length and drill a hole the distance between the valves on each side, and then weld this to this, and then I can just set this cap on here and clamp it down, and it'll be in the right position. So there'll be one for the intake, one for the exhaust, and there won't be any fiddle futzing around with getting it centered with the valve stem and stuff. So alright, so finished these guys on the mill. I found some long old screws. I was going to use these guys, but they're M7, which isn't a thing. But so I found these guys. They have more thread in them anyway. Instead of welding it to the cap, I just wrap some electrical tape around it. We'll see how that works. If it doesn't, I got a welder. I can make that happen. This will be okay for now, I think. Okay, so got this on the bench. Zero lift, put a little mark there. Made this in a previous endeavor. And I have a nice bell mouth that I can just jam on here and it will be consistent every time. So that's good. Turn the flow bench on. Okay, so there's your numbers. Means absolutely nothing until you put it in the spreadsheet. Okay, got all the intake flowed. Now, I'm gonna flow the exhaust. So now that I have the data from the flow bench, poke it into my Excel spreadsheet and it pops out some numbers. So as you can see here, the flow is about I think it's 267 on the intake and like 210 on the exhaust, 208 or something. So quite a bit better than the 230 I found on the internet. The exhaust flow percentage is pretty close to what you want. It's around 80%. I think it's like 78, like all through the 8 to 12 millimeters of lift. And it flows a little bit better. The low lift flows a little bit better, which is what you want with an exhaust port, right? Sometimes you even go to a 30-degree seat to get the curtain area to go up faster, because the exhaust valve you need that to open quickly, because you're essentially not pumping the air out in that regime when it's opening. You're letting it blow down, like you might have 20, 30 psi cylinder pressure still, and if you can open that valve quickly, you can utilize that small amount of pressure to kind of get the velocity of the exhaust going out the port, and then that carries all the way through. So it scavenges itself without the piston having to push it out. So that's a nice feature. I'd like to see it a little bit better, and I think we can improve the exhaust port flow by getting that giant step out of there. So now that I have this data, I can put it into my um, Performance Trends Engine Analyzer Pro program, and actually simulate the performance of the V10 with the turbos I'm going to use and with the intake manifold runner length and um, the camshafts, all that stuff. So you can put all the data in there that you're going to use. This is kind of a major one though. Without cylinder head flow, you really can't get started. So that'll be the next step in this endeavor, and then we'll play on the flow bench and see if we can get both of these numbers a little bit bigger. See what we have to do. Weigh the positives and the negatives, right? If we have to have new valves and new seats and new cams and new springs, like diminishing returns, right? So if I can use the stock stuff, I will. If it's a huge gain, I'll consider it. So stay tuned. Please add comments if you have any questions. I would be happy to. I'm doing this to try and educate people on what I know, so they don't have to learn it the hard way. So yeah, please put something in the comments if you don't understand what I'm talking about or want to call bullshit. That works too. Thanks for watching. If you like this content and want more, subscribe, like, and share.